Good afternoon, pre-algebra, or wow, pre-calculus. Can you tell I'm totally here with it today? So we have a snow day, and well, that means everyone kind of stays home. But as we homeschoolers know, that doesn't always mean that work doesn't get done. I know. And some of you are probably like, oh my goodness, why couldn't we have had a snow day? Well, here's the truth about why I decided to do this. First off, this lesson is pretty easy. It's pretty straightforward, and I think it's just gonna, be a quick application. And with it being a snow day and this being a video, you can watch it numerous times to remember how it goes, and we won't get off track with this year. So, yay! Okay. But for real, if you do have questions about it, please let me know. I'd be happy to answer your questions throughout the week. All right, so we are going to focus on the second part of lesson 17, which is graphing polar equations. Now, polar and rectangular equations can represent the exact same thing. The only difference is that polar uses this kind of a graph, where obviously rectangular uses our typical XY graphs. And polar is used to graph problems and equations where there are curves and circles and things that are not considered functions in a regular rectangular problem. So, for example, this is technically not a function. And over time, it does get, it is a little tricky how to graph this with a rectangular one, but, hey. We're going to see how to do that today. But like I said, rectangular and polar equations, there are three types that we're going to focus on today: lines, circles, and then the various shapes. I'm going to show you what that means here in just a minute. All right. So first, let's go with lines. What does this exactly mean? So if I need to graph something like this, theta equals pi over 4, all I'm going to do is I'm going to go to pi over 4, and I'm going to draw myself a line. Hopefully I'm going to darken that in enough for you. And that is my first equation. It's just simply a line. So graphing an angle just means you go to that angle and draw a line, not only where it is positively, but also it goes through the center and to its counterpart, or should I say its 180 over here counterpart. All right. The second one, if I were to graph theta equals negative 3 pi over 2, literally that just means we go to that angle, but we do the exact same thing. So where is negative 3 pi over 2? So negative 3 pi over 2 is, let's see here. Woo. So negative pi, boom. So again, I go down this way. And then this is technically negative 3 pi over 2. That's positive 3 pi over 2. This one would be negative. And that's my second equation. So just to recap on that one, instead of going 3 pi over 2 positive this way, where I go 1 quadrant, 2 quadrant, 3 quadrant, I just do the reverse when it's a negative angle. So 1 quadrant, 2 quadrant, 3 quadrant, and boom, there we go. Third one, it actually is the degree. So just make sure you know what that correlates to on the unit circle. 75 positive, that is 5 pi over 12. You can also look at your, convert this to degrees to figure out what that is, let's do it this way. Let's convert this to radians. 75 pi over 180 degrees. Get out that handy dandy calculator. Oh, look at all the things that I was calculating today. Just like graphs, I'm always plotting something. Do this, but then press your ABC button if you have something like this. Other calculators will just do it automatically. Sugar darn, look at that. 5 pi over 12. So that's this guy right here. We're going to draw that line. And that's our third equation, that one right there. All right, so that's graphing lines. So far, so good. Nothing too complicated. Now we're going to graph circles, and you're probably thinking, oh, no. Don't worry, the complicated stuff's on the back. I'm terrible. Okay, radius. The radius is 6, and that's where our circle is going to take place away from the center. So, wouldn't you know, we're going to come to our center, and we're going to go 1, 2, 3, 4, 5, 6. Whee! Every radius of 6 all around the circle is going to give us this right here. So this one is our first equation. That is radius equals 6. The second one, radius equals 3/2. Guys, did you know that that's actually 1.5 or 1 1/2? Shocker! So then we go back to the center, and we go out from the center 1 1/2. So there's 1 and there's a half. Do your best to circle that. Okay, well, my practice one was a lot better than this, but it's fine. This one is number 2. Last but not least, 3 square root of 2. Get out your little calculator. 3 square root of 2. 4.24, or about 4 1/4. So again, we go from the center. We go 1, 2, 3, 4, and a 4th pretty much. Make our way around the circle as best as we can. Definitely screwed up on that little part right there. Oh, looks like a half right there. I might have to go back and redo that. Okay, there we go. And that is our circle number 3. Yay. So far, so good. All right. So that's lines. That's circles. And now we probably get to the part that you're like, oh no. Yeah. This one does, or this next part here does take a little bit more time. You know, let me get rid of this other paper. Oh, yeah, you like my my spiritual warfare? Yeah, it's pretty cool. Okay. This one, you're probably like, ah! And maybe you should be. All right, when a radius does not equal just a number, but equals some kind of trig ratio, there's 2 things you could do. You could either rework this back into the X and Y stuff, or we can simply plug in values, find the corresponding parts, and then plug them in. I'll show you what this is after we plug in and graph, but for right now, let's plug in and graph. First, and certainly the scariest, is how do we plug this in? So first we go for cosine. We put our first measure in there, which is 0. Voila, it's 4. So this is 4. Okay. Oh, by the way, make sure this is in degrees. As long as you are plugging in degrees, great. If you're like, hey, I would actually like to plug in the radians, or like the pies out here, then you'll need to switch that to radians and then plug in these guys as you go. But for right now, I like to stick with degrees, so we're going to stick with degrees. Replace the 0 with 15, because 15 is the next degree. You know, maybe I should have explained this table a little bit. All right, this table, we have all of the angles up here. Again, they are in degrees. For me, it's just easier to plug in degrees every time instead of pi divided by this. And then down here, we're going to have the radius. So how far the point is from the center. So literally all I'm going to do is I'm going to plug in the value into where theta is, press enter after I plug it in, and then write down the coordinating point. And I'm going to do that for all of them. Exciting, right? Woo! Did not mean to hit my phone. Okay. So here we go. I'm going to do the first few with you. And then if you want, go ahead and pause. Do the rest on your own. Here we go. I'll do the first few. La la la. 2.8. Notice that I am doing correct rounding. Sometimes it's important, sometimes meh. All right, Holtage, how far are you going to go on this? I'm probably going to go till I find the negatives. Where are the negatives? There's a 1 once I do that. 0. Whoa. Oh, yeah, I was right. 105. Ah, there we go. Something I wanted to talk to you about before we continue on. Notice that all of this came to a certain number, and then all of a sudden the numbers start going negative, but reciprocating kind of what these are. So let me just guess. So this is 1, this is 2, this is, our next one's going to be negative 2.8. If it is, then I'm just going to, whoa, hello. Probably would help if I typed in the right thing. Oh, there we go, negative 2.8. So I'm just going to fill these in then for the rest of them that I know that I know. Okay. So now I'm going to plug in, because I know, and let's just double check, 180 is going to be negative 4. Voila. Now I'm going to plug in 195, negative 3.8 or negative 3.9. That looks familiar. So it looks like we're going to go all of these again. Negative 3.5, and they are going to be negative. Negative 2.8, negative 2, negative 1. And let's just check into 70 to make sure that that is in fact 0. Okay, so after 0, what do you think is going to happen? I think it's going to go back to the positives, but let's just double check just so we don't go through all of this to be like, oh man, we got it wrong. Which, by the way, you don't, oh, see, look, there's a 1. And then this is going to be a 2. This is going to be a 2.8, a 3.5, and a 3.9, and then a 4. You know you did it all right when the 0 and the 360 end on the same number. Why? Because they're the exact same point. All right, so what does this look like when we plot it? Literally, at 0, we're going to go 1, 2, 3, 4. And at 15 degrees, which is the next one up, we're going to go 3.9. So literally right there. Then at 30, we're going to go 3.5. So that's halfway point. Making my points kind of big. You don't have to make them this big. 2.8 is my 45. 2 is my 60. Yep, 60, there we go. 1 is my 75, and then 0 is my 90. Now, these negatives here, we are going to go ahead and plot them, but just so you know, the negatives most likely will come back again as positives later, but let's go ahead and go forth and just see what happens. At 105, so that's this one right here. At 105, it becomes negative 1. So I would say that this is negative 5, 1, but 105, negative 1 flips over the axis and comes right here. So then 120, which is this guy, negative 2. So I would do 2 right here, but it flips over and does this to the axis. We're going to keep going with these negatives. Let's see here. It's 2.8, and then 3.5, and then 3.9, and boom, negative 4, because it would go 184, and then it would backtrack over here. If we were to continue with these negatives, the same circle would continue to take place. You can always double check, but this is our final shape. Look at that beautiful little circle. It's so cute. An off-center circle, and you're like, what? We can totally do that with rectangular. Yes, we can. Let me show you how. We're going to do this very quick. You do not need to do this for the homework. This is just me showing you because I'm a nerd. Okay, hang on. You know, it also would very much help if I didn't, like, you know, lose my spot in my notes, right? Okay. So this guy over here, we've got r equals 4 cosine theta. One of the, I'm sorry, here, let me put it this way. X equals r cosine theta, right? But that also means that x divided by r equals cosine theta. Whoa! Instead of cosine theta, we can just simply say 4x over r, because that's what cosine equals. Multiply both sides by r, and we get r squared equals 4x. R squared can also be replaced by x squared plus y squared. There we go. And you're like, I still don't see a circle that is worth mentioning. Let me tell ya. This guy, we're just going to bring him over here, okay? X squared minus 4x. We're going to go plus blank plus y equals 0. Y squared. And you're like, why in the world would we do that? Because all of the x's and y's need to be on the same side in order to find the true equation. What? Well, then why'd you leave the blank there? Because my little foresight told me, hey, you know what? We have an x squared, we have an x. If we have a third term, we could make this into a polynomial. Meaning, I'm going to do completing the square. If you don't remember what that is, look it up online. But again, this is a nerd moment, so you don't have to. This little guy right here, you take this guy, so -4, you divide him by 2, -2, and then you square it to get this number. That would be a +4. What you add to one side, you have to add to the other. And then this guy, once you complete the square, this becomes x minus 2, because it's this guy divided by 2, squared, plus y equals 4. Sorry, that's a y squared. And you're like, this still doesn't help. What are we talking about? Let me finally show you and reveal this masterpiece to you. Oops, I'm so sorry. I always get really excited and then it all falls apart. These two equations are the exact same thing. This shows you how far from the center of the circle it goes. So I'm going to bring this over here now. Whoa! Do we all have whiplash yet? Of course we do. X minus 2 squared plus y squared equals 2 squared. This means we have a circle. This means that the center will be offset by 2 in the positive direction. So look at this. 1, 2. There's the center of the circle. And it will have a radius of 2. If this is the center, look at the radius. It's 1, 2 over, 1, 2 over. And if we were to measure it, it would be that all around. Pretty nifty. Do you need to know all of that? Absolutely not. It's just fun and cool to know. What you need to know for this lesson, though, is how to fill in these guys by plugging in, and then how to graph them here. So I'm going to get us started on this one. I'm going to pause once we get to the negatives. I'm going to give you a chance to fill in the rest of the circle, or I'm sorry, the rest of the chart. And then, and then we'll go to graphing. We'll do these two and we'll call it a day. So let me show you how to graph this one. All right, so we have 8 divided by, I'm going to do a big parentheses here, 2 cosine, our angle is, or 0 is our first, and then minus 3 sine, 0 parentheses, and then I have to close out the entire denominator, otherwise it won't catch it all. All right, oh, looky that, it's 4. Okay, so then how do I keep going with the 15 degrees? I'm going to come in here. I'm going to say insert. I'm going to put my 15 in there, and then I'm going to delete the circle. The circle, wow, the 0. I can't function today. Insert a new degree. Get rid of the circle. Oh my gosh, the 0. I can't. All right, 15 degrees has been plugged in. Equals 7. All right. Now we're going to go back through and we're going to plug in 30. I think this one, if I remember in my... Is that tangent? What? How'd that get there? It's supposed to be sine. Uh-oh. Okay. Ah! We're just going to replace both of this with 0. 0, 0 means the same thing. Oh my goodness. I hope I didn't screw this up. Oh, okay. So it's still 4. Whew. Man, I'm so glad I caught this now. Because I was like, I don't think that's actually right, but that's fine. Please don't be too far. Oh, okay. All right. Does the decimal point matter? Actually, it does. I always give myself at least 1 decimal place. It really does help me graph better. Okay. Whew. I about peed my pants. Okay, this one, 34. That's all right. Just know we're probably not going to be graphing that. It's just really far. Just kind of like in a regular graph when you're like, oh, that goes off the page. It's nothing to worry about. Just make sure you get everything else plugged in. Oops, I just realized I screwed that one up. All right, 45 has been plugged in for both. Negative 11. Is that negative? Hang on, I gotta check my notes here. Nope, okay. All right. Negative 11.3. Now we have 60, 60, negative 5. And I'll go all the way to 90, and then I want you guys to work on the rest. Negative 3.4. Negative 2.7. All right. Keep going. Please complete the entire chart. You will see some repeats of numbers, probably positives and negatives, but please go ahead and fill it all out. And when you're done, play the video and I will show you what the rest of the terms are. I already completed them just so this video would go by a little bit faster, but I do want you to get into the habit of plugging them in on your own because I know, I'm not going to complete your homework for you. Like, what kind of a teacher am I? All right, go ahead, hit pause, complete the table, and then hit play. All right, if you have hit play, that means you are back and we are back in action. So the rest of these are, we got negative 2.3, we have negative 2.2, we have negative 2.3. I'm starting to see a little bit of a repeat here. Negative 2.5. Wait. Oh, well. Negative 3. Thought I saw a repeat, but I guess I was wrong. Negative 6.9. Negative 3, 4, 5. Oh, I do see a repeat now. Well, hello, everybody. Only this time, it looks like everybody's going positive. All right. I jumped ahead of myself. I do apologize. The repeat didn't happen till way later. 2, 3, 2, 5, 3, and 4. 4 and 4. So far, we are great. All right. This should be your completed table. Take a moment now. If this is incorrect, pause the video, correct what is incorrect, go into your calculator, figure out what you did wrong, and then play the video because we want the correct terms in order to graph this correctly, right? Makes sense. Okay, here we go. At 0 degrees, we have 1, 2, 3, 4. At 15 degrees, we have 6.9. So that is, let's see here, that's 6. So that's almost 7. That's that guy out there. And then at 30 degrees, we have something way out in who knows wheresville. 45 degrees, we have 11 point something. So that's way down here in who knows whatsville. But at 60 degrees, we have negative 5. So we're going to take the 60. We're going to come down here and we're going to go 1, 2, 3, 4, 5. All right, at 75, we have negative 3, 4. So bringing the 75 down here, negative 1, 2, 3, and a little under a half. And let's keep going. Negative 2.7 at the 90. So negative 2.7, about right there. Let's see here. 105, that is negative 2.3. So we're bringing this down 2.3. Next one is 2.2, and then next one's 2.3. Can you kind of tell the shape that we're going for here? 2.5 is 150, but remember it's negative. And then 165 is negative 3 exactly. And then 180, but with a negative 4, lands us back here. If you check the positives, oh wait, we forgot to go all the way. My bad. So negative 4 and then negative 6.9, so that's 195. 195, oh yeah, 6.9, there we go. There should be another 6.9 like over here somewhere. Oh well. This is our graph. Oh wait, no, it's a 5 right there. There we go. That's our graph. It is actually a line. If we were to rework this, the equation we would find is y equals 2 over 3x minus 8 thirds. Now, this is just a nerd moment, but look at this. So this would be 3 goes into 8 2 times with 2/3 left over. Negative, if this was a, what am I trying to say? Rectangular graph, we would go down 2 and 2/3, boom. And we would rise 2, run 3, rise 2, run 3, 1, 2, 3. Boom! That's kind of crazy. But yeah, so even if we were to graph this rectangularly, we would still find that same equation. It's just a matter of if you want to use, plug in all the points, or if you want to use this. Last one, and then we got to call it good. This one, same story, second verse, we're going to plug in values and then we're going to graph them. This is the only one that I have really struggled to actually find an equation on. I can't, and even in contacting the old instructor, she couldn't either. So please don't try to turn this into rectangular. But I want to give you a moment to do not only the table, but the graph on your own. So pause the video, do the table, do the graph, and then when you're done, play and we'll compare notes. All right, welcome back. If you have hit play, that means we are ready to go for this part. So here's what I got after I plugged it in. If you find that yours is different from mine, go ahead and take a moment and correct it. If I am seriously wrong, send me an email. You guys know how this works. That's Carl and Gabe in the other room. You can probably hear them. Wow. They are winding down for nap time, which is in about 30 minutes at this point. If you were at all disappointed that there were not really any repeats here, sorry. Like, it looked like there probably was some, but then it, well, actually, did it? Oh, it did repeat the whole rest of the way. Huh. Cool. All right. If you graphed it, this is what your graph should have looked like. So come out here, 0 is 6, 5.9, 5.6, 5.1, 4.5. Hang on, let me just double check that. 1, 2, 3, 4.5. Okay. 3.8. Three. Wow, that was huge. 2.2. 1.5. Oh, this is getting close. 0.9. 0.4. 0.1. Oh, I'm off by 1. There we go. And then 0. Sorry, I think I'm off by 1. At 180, it should be at the center. So then we start our backup at the 1.1 or 0.1, 0.4, 0.9, and then 240. Wow, this looks a little special down here. Okay, let's just start back up at the 180. So 180 is there, and then we have 1.1, and then 1.4, 1.9, 1.5, or 0.9, 1.5. I know what I'm saying. Let's just hope I know what I'm doing. 2.2, 3, 3.8, 4.5, 5.1, 5.6, 5.9, and 60. All right. So it looks like we have kind of this very full heart going. Like if you were to draw a picture of a heart and then inflate it with air, that's kind of what that looks like. All right. So guys, for this next week, all I'm asking you to do is graph and be happy. All right. Hey, if you got any questions for me, please text me. Email is not my fastest means of communication. Some of you have figured out. So please text. Watch this video as much as you want, and I'll see you next week. Please make sure that you send in your homework either by email or by text. Again, text, you're going to get a lot quicker response from me. And yeah, okay. I think I'm done. Bye, guys.